Okay, so we're going to do another problem out of Taylor's Classical Mechanics textbook. This is question 7.9. Before we begin, if you wouldn't mind please liking the video and subscribing. I will be posting more mechanics videos in the near future, so you'll never miss the videos if you subscribe. And this is question 7.9, which is essentially we're going to have a bead around this circular hoop with the radius r in the xy plane centered at the origin. So that's essentially what I have here, just a circle O. We're going to have some beam around the, so we'll let that yellow thing be the bead. And it's kind of confined to this hoop. And of course the origin's at the center. It has a radius of r. Okay. And it says use the angle phi of the two-dimensional polar coordinates as the generalized coordinates to describe the bead's position. Write down the equations that give the Cartesian coordinates x, y in terms of phi, and give the generalized phi in terms of x, y. Okay, so I'm going to just draw a vector from the origin to wherever the bead is. Okay, and we'll call this angle here phi. This is the x coordinate or component, that's the y component. So if you want to find the x and y, it's pretty easy. It's just a triangle. So we can say x is just going to be r cosine of phi, and y equals r sine of phi, because this is also distance r. And if you just remember, so TOA, right? You can find those different components. So here is x and y in terms of phi. And then if you want to find out what phi is, well, that's also pretty easy. You would use the other one. Tangent of phi equals the opposite over the adjacent, so y over x. Taking tan inverse of both sides, phi is tangent inverse y over x, which we kind of already knew this. I'm assuming that this problem or this information will be used in another problem, but this is pretty easy. This was the next question, so I did it. And hopefully that helps somebody.